welcome back to Lesson 12, Part 3, where we're talking about mapping with cartopy. In reality, every map is wrong in some way. Here, we have a map that's pretty common. We see Canada and Greenland and Russia, and they all look pretty big. And then Africa looks kind of smaller. But when you look over here and we try and compare land area, you can see China and Mexico, Western Europe, India and the United States, they all fit inside of the land area of Africa. And even the size of Russia is about half the size of Africa by land area. So why does it look so much bigger here than Africa here? Part of that is to do with the surface of a sphere being different to the two-dimensional plane that we're squishing it down onto. So we have to cut the sphere somewhere in order to lay it flat so we can see the whole thing, which means we can't represent it on these planes without distorting it in some way. That's why at the poles we end up with sort of all of the stretching and things get bigger, and things at the equator sort of get squished, and it can tend to do some weird things to data if you're not careful, which means we have to think about our projections to visualize our geographic data, because even if maps are wrong, it doesn't mean they're not helpful to see what's going on. So we want to be able to project our data in a way that doesn't make it look strange or try to highlight big areas, but really just shows the trends of what's happening. So here are a few projections that are available in the package we're going to be using, which is cartopy. The most commonly used ones here are the plate carré, the Robinson, the Mercator, the orthographic, and the interrupted good homocene. But there's a full list of projections available on the documentation here that you guys can look up. And it's good to test out a few different options, but these ones tend to be the most useful depending on what you're looking at. So now that we sort of know about projections, let's think about how we're going to apply it to loading our data and plotting those things. So first we want to load cartopy. Since cartopy is not readily available in Google Colab, we have to load it into our notebook before importing, and that's very similar to the netcdf file. So we have to run these 3 lines. This one actually installs cartopy, and then we actually have to uninstall and reinstall a lower version of a package that doesn't play so nicely with cartopy. This is one of those things that you only run once in your notebook and then comment it out, and then you're good to go. After we've got cartopy all loaded in, we have to import it. And we're not going to import just cartopy, we're going to import a few of the different classes from it. So we're going to say import cartopy.crs as ccrs. And that helps with getting our projections and being able to do that without having to do it by ourselves. And then we can do import cartopy.feature as cfeature. And that helps create map features like land and rivers and borders and states and things like that. And then we have from cartopy.mpl.gridliner, we're going to import longitude formatter and latitude formatter. And what that does is it makes our axes really pretty. So let's start with creating a coast. First, we're going to create our figure, fig equals plt.figure, and we give it a figure size that's not unreasonable. And here's how we create our projection here. So we say ax equals plt.axes. Remember, that's just creating an axes object. And then we give it the argument projection equals ccrs.plotcarré, and that's a function, so you put in parentheses there. So that creates this projection, and now all you need to do is put a coastline on it. So then you say ax.coastlines, and the resolution and color are optional, but you can have a low resolution of 110 meters, sort of a medium resolution of 50 meters, and you can see it's sort of filled out a lot of that. Or you can have a high resolution of about 10 meters. Note that if you go 10 meters, it's going to slow down your code a lot. So you got to be thinking about the area you're plotting in and if you really need that high of resolution. You can also change your central longitude. So here I create a figure, and this is a new way to add an axes. So here we have ax1 equals fig.add_subplot, and then we give it the number of rows, the number of columns, and then which subplot we're plotting on. Notice that this is a 1, and that's because it's stealing from the MATLAB format. But this is going to be 1, so it's going to be plotting on the left side here. And this one, we're going to be plotting 2, so it's going to be plotting on the right side. So we add our axes, and we give it the projection of plot carré. And this one, we give it the argument of central longitude equals 180. And what that does is it makes the center of the map at 180 here. Then we put our coastlines and it looks like this. Whereas if we do ax2 equals fig.addSubplot, 1 row, 2 columns. Remember, it's the same argument here. And then we're just going to the second subplot, so the second axis here. And we say projection equals ccrs.plot_, but we don't have that central longitude, and see now it's centered at 0. So now let's add a grid to our coast. So here we just create our figure. We say plt.axes, because we're not doing a subplot anymore. And we say give it our projection of plot_, and we have ax.coastlines, and we have a resolution of 110 because I don't need to be plotting really high resolution for global. And then to do our grid lines, we say GL equals ax.gridlines, and we say CRS equals CCRS plot_, with our parentheses there. That's the only required argument for this. The rest is optional formatting, but draw labels means that you're going to actually put your numbers next to those lines. Line width, color, alpha, line style, all of those things for formatting just how it looks. So now we can format it even further, and we can say gridlines.xlabels top. So notice that the ones on the top are gone now because we turned them off by saying false there. And the same thing goes for the y labels on the right, which is now false, and those are gone too. And now if you'll notice, we also said gl.xformatter equals longitude formatter, and gl.yformatter equals latitude formatter. And if you look at the difference between this one and this one, you can see that now these are formatted with their degrees north, degrees south, degrees west, and degrees east, rather than negative and positive. So now that we've put a grid on and we formatted our axes a bit, let's add some features. So here we have ax.addFeature, and we use the function cFeature.land for getting our land, and you can see I colored it in as papaya whip. And then we have ax.addFeature, cFeature.ocean, and I've colored it in with cornflower blue. So you can see it just creates sort of these shapes of the ocean, of land in these areas. Now these features are 110 meter resolution, but we'll talk about how to get those at higher resolution if you're plotting closer up. But first, let's zoom in a bit. So here, let's set our extent, and that just means that we're going to set our corners. So we're going to set -170 to -70, and then -15 to 50, and it'll put it on the map so that those corners are aligned. And here we can see we've selected out sort of the continental US, plus a little bit of Hawaii and a little bit of Alaska there. So again, that x.setExtent allows you to set those things, and you give it the x coordinate, then the other x coordinate on the right of it, and then the y coordinate below and y coordinate above. And now let's add some more features to this, right? So now we can add our lakes. You can see you get the big lakes here in that navy color. And I'm actually going to add some rivers. And here's how you add it with a little bit higher resolution. So you say cFeature.rivers.widthScale 10 meters. So that's getting all of the tiny little rivers in there at 10 meter resolution. You can see I use edge color instead of just color because it's a line, so you really just have edges. And then here we say cFeature.states. So you can see I'm drawing my state borders here, and I say edge color equals K. So it's a black border there. And then finally, let's actually put data on this map. So we do all of the things, we format it, we get all of our features, but let's actually plot some stuff. So here I've got the coordinates for Seattle, -122.33, and then 47.61 or so. Then we have the coordinates for Honolulu. So we have -157.858, and then 21.307. So here we can say ax.plot. Notice that it's the same function, and we give it the longitudes, so Seattle of 0 and Honolulu of 0, and the latitudes, Seattle of 1, Honolulu of 1. And we give it our line argument here. Remember that shortcut that you can put the color, the marker, and the line style together. And I did a nice fat line width. And here's how you actually put it on the map here. So it's transform equals ccrs.plot_. So So that's our original projection. Now, if you wanted to do a different transform, you could, but it would change how the line looked a little bit. So you can see here we do the same plot, but instead we do transform CCRS geodetic. And the difference between that is that the plot query is the shortest space between Seattle to Honolulu on this flat map. The geodetic is the shortest space on the globe. So you can't go straight across like that. You actually have to go around a little bit, and that will be the shortest distance on the globe. So let's put that all together for our oxygen data that we had. So we have our file path, we read in our oxygen data, and now we're just going to take the latitude and the longitude, and then we're going to take just the surface depth there of our oxygen from our World Ocean Atlas. Then we create our figure, and we create our axes with a projection of plot query, and then we do our p-color mesh. And notice that it's the same arguments, except we're just adding one more of this transform CCRS plot query. Same thing with the contour lines on top. You can just do the same arguments, level 17. You just have to give it that plot query transform in the end. And then we can label them, and because it's directly linked to this contour plot, that works well. And then formatting, putting on a color bar, setting a label, and then we add this feature for land. So I color in the land and make it dark. And then we sort of put on grid lines. So we have our little dash grid lines in white. And notice that we again have to have our CRS equals CCRS.plotQuery. And we are drawing our labels, but then we turn off our top and our right label, and we format them nicely, and we set a nice title. And that would be a figure that you could save and plot. So that is all for this mapping. These are all of the resources I used for the entire lesson. Here are some great tools for the cartopy stuff if you're feeling lost or confused. Contour is also here. This is the documentation for p-color mesh. And then this is for just about talking about how every map in the world is wrong. Hope you guys enjoyed, and I will see you guys on Thursday in class.